In this video, we're going to talk about a major feature of modern programming languages and Python called object-oriented programming. We currently have been using procedural programming, and it's writing a program made up of functions that perform specific tasks. Procedures typically operate on data items that are separate from the procedures. So you'll declare a variable, then you'll declare a function that takes those variables as parameters, and they're not necessarily interrelated. Data items are commonly passed from one procedure to another, and the focus is to create procedures that operate on the program's data. The object-oriented paradigm switches that a little bit. It's focused on creating objects. Objects map to real-world entities. An entity that contains data and procedures. Data is known as data attributes or member variables, and procedures are known as methods. Methods perform operations on the data attributes. Encapsulation is the idea of combining data and code into a single object. So instead of having a getPerson function, we would have a person object, and that person object would have member attributes or members such as name, first name, last name, address, etc., and methods like print address. Okay, so an object contains data and called member variables or attributes, and methods that operate on the data. Data hiding is the idea of an object's data attributes are hidden from code outside the object. Access is restricted to the object's methods. This prevents from accidental corruption. Outside code doesn't need to know the internal structure of the object. The reason we want to do data hiding is, think of this example. When you drive your car, you have an outward interface called a steering wheel, right? Or a gas pedal. Let's see, that's a better example. A gas pedal. When you press on the gas pedal, the car goes. Okay? What you don't know is whether you've got a gas or electric engine. Okay? Because that's abstracted away, that data is hidden, and the idea of a gas pedal is encapsulated. One big advantage of objects is they can be used in different programs. For example, you use a 3D image object for use in architecture as well as a game program. Okay? So basically, an object is an encapsulation, and code outside the object actually uses it. So let's take a look at an everyday example. Data attributes or members variables define the state of an object. For a clock object, would have a second, minute, and hour attribute. And it would have public methods like set time and set alarm. It would have private methods for the internal objects working. Okay? A class is code that specifies the data attributes and methods of a particular object. Think of it as a blueprint or a cookie cutter. A class and an instance are not the same thing. A class is the cookie cutter. An instance is the cookie. If the class were dogs, an instance would be my dog Charlie. Okay? It would have features, it would have member variables specific. The class would have member variables generalizing the object type, and the instance would have specific ones, like naming one my dog Charlie. Okay? One way to look at it is, here's the blueprint, and then here's each of the houses. This would be the class, this would be the instances. So here's an example. The insect class describes the data attributes and methods that a particular type of object may have. So we got an insect class, and then an instant of housefly object or mosquito object. The housefly object is an instance of the insect class that has the data attributes and methods described by insect. The mosquito is also an instance. It has the same data attributes or members and methods. So how do we define a class? It's a set of statements that define a class's methods and data attributes. Format begins with class name. Class name often starts with uppercase letters. The method definition pretty much looks like any other Python function. However, they have a special parameter, self. Self is required in every method in the class, and it references the specific object that you're working on. So going back to our example of pug, the Charlie instance would have a self parameter referring to it and its own methods. So let's take a quick peek at how we actually would do this. Okay, first we create a Python file, and then we'll say We'll call this dogs, or dogs2, because I already have a dogs class out there. We'll say example, simple class definition in Python. Okay, so what we would say here is class dog colon, and then here we can define methods. Now, the thing about Python is you need to define your instance variables in methods, or else they become what are global variables. Now, class variables. A class variable refers to every instance of that class. So, for example, if you have a dog, you could say its species equals Canis familiaris. Okay, that's available to every instance of a dog. Okay, now let's say we want another method. I don't want to do this yet. We'll say def. I can't type today. Def get dog, and it will return, and it will take self, and in it we will create our own instance variable. Instance variables are defined either in a constructor, which will come to next, or a method with self passed in, whereas class variables are defined with without. So we'll have a get dog. Okay. And first, but before that, let's build def set dog, and it will take self and a breed, and we will initialize them. Notice we refer to self. That means this instance of dog. Okay, we'll set up its name, breed, height, and weight. And so get dog, all we got to do is return self, because we want the current instance. Okay? And then out here, let's define another method, say hello, which will print details about the dog. All right, so now we will build some driver code. And we're going to create a new instance of dog. We say Charlie, which is the name of my pug, okay, is a dog. Okay, now what we can say is set dog pug Charlie. Say he weighs 1.5 pounds, or he's 1.5 feet tall, and he weighs 25 pounds. Now we'll define my other dog, Moose. Moose is a Jack Russell Terrier, and he's 2 feet tall, and he weighs 15 pounds. So now we can access the class attributes and methods through objects. Okay. We can also say, so for example, we can say print Charlie get dog, right? And that will print an instance of Charlie in the raw. Which is a dog object. Notice we got this object ID. It doesn't really tell us much. So we have our dog Charlie, and what we can do is, because we're getting an instance, we could either capture that instance, or we can just call from it. Print Charlie, say hello. Okay, save that. And here it prints it. What's that? None. But notice, when we call, we don't pass in this. The reason we don't pass in this is Charlie. And so when it comes into here, Charlie itself is referred to as self. That's a little different than many object-oriented languages. So that's a first step in creating class. The second step would be to create an initializer method. An initializer method automatically executes when you create a new instance. It initializes the object data attributes and assigns self parameter to the object that was just created. And it looks like this: def underscore underscore init underscore underscore self. You can give it more parameters, but usually it's the first method in a class declaration. So how does it work? An object is created in memory from the coin class when we say, coin, new coin equals coin, left, right, parentheses. The coin class's init method is called. Self parameter is set to the newly instantiated object. And then we can set our member parameters, or member variable. After these steps take place, a coin object will exist with its side up attribute set to heads. Now this isn't very flexible because we make every coin say heads. Why not just have a class variable? Instead, what we can do is use parameters. But first, to create a new instance of a class, call the initializer method. Format myInstance equals class name. To call any of the class methods using the created instance, use the dot notation. Because self parameters reference the specified instance of the object, the method will affect this instance. The reference to self is passed automatically when you call a method here. It would pass myInstance as self. Okay, we can hide attributes and storing classes and modules. An object's data attribute should be private. Okay, to make sure of this, place 2 underscores. What this basically means is we only want to make visible data to the outside. From there, we can, or make private, we can only make it to the outside. So for example, you wouldn't be able to access current minute. Instead, you have a get current minute method. Okay, so let's draw some examples from that. So if you remember before, when we said print an object, it printed some huge number, which is actually the object ID, instead of actually the contents. There's a method in every class called underscore underscore string underscore. And basically it allows you to print the object state however you want. Okay, so what we could do is, in the case of before, we could take in our dog class, we can override, it's called overriding string, pass itself, right? And then we can print it out however we want. So then when we go to run it, I'm going to copy out some code here. When we go to run it, it will print out Charlie's a pug and weighs 25 pounds. I've added some other code here. The other thing I've done with this is I've made it a library. I put it in its own file. Okay, and so what we can do is we can now in our function here, let's say we want to import dogs2, and so we'll declare a dog, right? Okay, whoops, didn't mean to do that. And so now we've got a dog, and now we're going to print Charlie because we've defined our print method, and then we're also going to call say hello. Okay, and so it's our own little library. And I screwed up an index. Alright, let's try that again. And alright, my instance appears to have died, so give me 1 sec. Actually, my instance didn't die. I was thinking ahead of myself, and I would say, there we go. I forgot that part, so I'm printing anything. Let's run that again. And then here we go. It prints out Charlie's a pug, because we defined in our docs2 our string override, right? And then we, oops. And then here we call Charlie.sayHello, and that worked, and Charlie.print also worked. Okay. So now we're going to talk about working with instances. An instance belongs to a specific instance of a class. Okay. It's created when a method uses the self parameter. If many instances of a class are created, each would have its own set of attributes. So here, each of these has their own set of attributes, and you can have one be tails, and it would be its own. Okay. Accessor and mutator methods are how we typically allow the outside world to access the member variables in our class, because that way we could change it. Okay. So for example, we come back here. Go to our our dogs library. We could have a function set breed where it only accepts Pug or Jack Russell, otherwise it prints unknown. Okay, if you could modify it directly, you could set it to anything, but now we've restricted it. So let's come over here and let's change our Pug to a Puggle and run it. And what do we get? Oh, sorry, that won't work. Let's leave this as a Pug. And say Charlie dot set name or set breed. And we change it to Puggle. And now we run it. And its breed is now unknown because of that if. So we can use this to restrict how our stuff is used. Okay. Additionally, and those are called accessor methods for the gets and mutator methods for the sets. Additionally, we can pass arguments as objects. When you pass an argument as an object, you are passing a reference to that object. Okay. The received method or function has access to the actual methods of the object as if it were its own object. So we're going to demo that in just a second. Let's demo how you can use objects as arguments. Okay, let's take our original program here. Let's go back to our original, and we're going to create another class in here that we're going to call family. In the family, we have two pieces of information: family name and a list of pets. And we'll have our get and set. We'll also have a method called add pet, which will add a pet to our list internally. And then we will print all the pets. Okay, so if we come back over to hello, we can now say family, family equals family Smith, Charlie Moose. And now we can say print the name. I forgot the dogs too. And we can also print the family. And then we can also call a routine. Family display pets. Okay, and we can also let's add another dog. Say dogs two dot. Family dot add pet. All right, and then now we catch this and we run it. We will see that it printed out all three. And so now we've shown that we can contain objects within other objects. Okay. And so with that, last thing let's talk about is how do we find the classes in a problem? Well, typically you identify the real world objects. Here's a way to get onto it. Write a description of the program, identify all nouns, refine the list to include only classes that are relevant. Then we should find all the verbs, which will then tell us the methods in the class. Okay? We should always make sure to identify the class's responsibilities clearly. Okay? And telling us what is in and what is not in the class.